how would we get any work done without energy? Energy is the ability to do work, and it's what we need to run our homes, our cars, our devices, even our bodies. And the same is true for the organisms out here in the ecosystem. The ecosystem needs energy to function, and we can trace the energy flow through an ecosystem, and that can be part of how we test how healthy an ecosystem actually is. So let's take a look. It's so bright out here. There's so much energy coming into this ecosystem. This energy comes in the form of light, but that light is not directly usable by the organisms here in this ecosystem. Good thing there's a process that takes place, an incredible process, and it happens right here in these leaves. Photosynthesis is probably the most important biochemical reaction on Earth. The sunlight shines down on these leaves, and the energy is transformed into chemical energy. That chemical energy can be distributed to other organisms in the ecosystem. Organisms that can take energy and turn it into chemical compounds or organic compounds, like carbohydrates, are called producers or autotrophs. Auto means self, troph means nourishment. So an autotroph is a self-nourishing individual. They can make their own food. These trees right here in the ecosystem are autotrophs, are producers, and so are all the other plants here in this ecosystem. And because they use light energy coming from the sun to make the food, to make their nourishment, they're called photoautotrophs. Photo means light, auto again is self, troph is nourishment. So this is self-nourishment from the energy and light. They're called photoautotrophs or producers. Once the energy is transformed into organic compounds, it can continue through the ecosystem when an organism eats a producer. Organisms that depend on other things for their organic compounds and to get energy, those are called consumers. Consumers are organisms that depend on other organisms for food. They take in organic compounds for energy by basically eating other organisms. They're consuming them. That's why they're called consumers. Another term for a consumer is a heterotroph. Hetero means different, troph means nourishment, so a heterotroph gets its nourishment from a different organism. It cannot get the nourishment from itself. It can't make its own food. If the consumer eats just plants, it's called an herbivore. So it just eats just plants, herbivores. Let's take a look at a few examples. If an organism eats just meat or just eats other animals, it's called a carnivore. Carnivores eat only other animals. They don't eat plants. Let's take a look at a few examples. If an organism eats both plants and other animals for food, it's called an omnivore. Omnivores eat both plants and animals, and that's how they get their nourishment. Let's take a look at a few examples. Some organisms are called scavengers. Scavengers eat soft tissue of dead organisms. So things like vultures They feed off of the soft tissues of organisms that have died, and those are called scavengers. When organisms die, they leave behind matter and energy in their remains. Organisms that are called decomposers can break down these remains and get the energy for themselves. They also, in the process, release that matter, that inorganic material, back into the environment, that it can be reused. Decomposers include things like fungi and bacteria. And just like producers, decomposers are essential to the ecosystem because they put those nutrients, those inorganic compounds back into the ecosystem. It's a recycling piece, so they're necessary for the ecosystem. So mushrooms are an example of decomposers, and they break down the remains of dead organisms. They get energy from that, but they also release those inorganic compounds back to the ecosystem. An ecosystem absolutely needs producers to be able to take the energy that's coming in from sunlight and convert it into organic compounds that can be used to transfer the energy through the ecosystem. But it also needs those decomposers to be able to break down the remains of any organism to return nutrients and other compounds into the ecosystem so that producers can use it again in order to make those organic compounds with the energy from the sunlight. We can follow the flow of energy through an ecosystem in food chains and food webs. Food chains are very simple. They show one pathway that the energy can take, and they're not very realistic. Food webs show more pathways of where the energy can go, and they are much more realistic. They show that organisms can be eaten by more than one thing, so there's an opportunity for the energy to flow in various directions. They're much more complicated, but they're also more accurate in the way that they depict energy flowing through an ecosystem. Each level in a food chain or a food web is called a trophic level. Trophic referring to nourishment, so it's a level of nourishment. There are generally about 3 trophic levels in a food web or a food chain. They can't go on forever, and so usually maximum it's like 4 or 5. Those trophic levels can't go on forever because there's the idea that only about 10% of the energy gets passed from one level to the next. So what happens to the other 90%? Well, the organism at the previous level uses it for itself, or it loses it off to the ecosystem as heat when it's doing work. So even though it has all this energy at a level, only about 10% gets passed on, which means that the energy levels, the trophic levels, can't go on forever. Eventually, it's going to run out of energy. This loss of energy explains why there's usually only 4 trophic levels in a food chain or a food web. It also explains why there's fewer organisms usually at the top of the food web or the food chain. You know, all this talk of energy and organic compounds like carbohydrates, sugars, making me really hungry. And this video took a lot of my energy here to make. So I think I need to go replenish that energy. I think it's lunchtime. And I guess I should thank my fellow organisms for that.